Hello. Okay, so today, welcome back to the Space Engineers Tutorial Project. This is episode 11, and today we're going to be covering wheels. Now, wheels of Space Engineers come in two variants. They come in the non-steerable and steerable varieties. The first variety has no suspension, no power, propulsion, and they have no steering capabilities, and the second have all of those. Most of the time you're going to be using wheels on planets to propel your rovers. But wheels have very high impact resistance, and sometimes they're used as shock absorbers on builds that will impact a lot. Another use is for them to be used on designs such as a crane or other items that require large parts of the build to move. In these cases, you have to experiment with track design and the carriage design, etc. That's down to what you're going to build. But I won't be covering those builds here, but you guys go nuts and experiment with those. With the information you are going to gather in this episode, I will show you how wheels function and how to set them up. I will also show you some of my design ideas for Rover chassis and how they can be incorporated into using wheels for a rover. One other thing with wheels is their build stages are useful if you're wanting certain design aspects on your design, on your builds. If you grind them down, they look kind of cool, and you can use them for different things. But I won't be covering those today. Those are things that you need to experiment with. Okay, so all wheels come in three sizes. Let's get into our character and let's have a little walk around, and I'll show you what I've got set up over here. So I've got three sizes for wheels, and those are simply, let's go around this side first, show you the non-steerable wheels. We have 1x1, 3x3 and 5x5. Yeah. And that just denotes how many blocks they take up, and that covers both grids, large grid and small grid. Okay, so 1x1 is 1 block by 1 block, 3x3 is 3 block by 3 blocks, and 5x5 is 5 blocks by 5 blocks. Important to note here with the suspension variant, which is these 1x1, 3x3 and 5x5, they have a little nugget, which I call a nugget, or you can call it a nipple if you so desire. That thing there on the arm of the suspension, you see on these, that must be at the top. I'll cover that why in a minute. Okay, so first things first, let's build a rover. I want to show you a little design trick that I use, and it's the build frame. Okay, and this is it. Just drop that in. This is easily achieved. You just get a block. I'm using a small grid one because most rovers are going to be on small grids. Excuse me. You can make large rovers. They're just a lot more cumbersome, but they do fulfill a role if you've got them in mind. So the way to build the frame is you just drop a block in air and then you just build off of it. Okay, it does help if you've got the right block selected. So you just build off of that, like so. Right, now I'm going to delete that, and then you end up with a building frame like this. When you've finished your design, because you'll build off of the top there, you just cut away the top block, delete the frame, and away you go. Okay, gives you a nice stable platform to work from, so that it's not going to fall over, etc., etc. So once you have the base platform in place, just build a frame, which we call the chassis, which is this thing here. Okay. Now, I use angled blocks, as you can see here on there, for the wheel mounts. You can use the different designs you see here to lower and higher the ground clearance. You always must consider ground clearance. So in order to get larger or smaller ground clearance, I use these. Now the ones on the top give a lower profile, so the frame will be lower to the ground. You can see when you put a wheel on it, okay, the wheel is actually higher than the frame. On this one, I use one block angled down and then another one turned to make a face, and that will lift the frame because the wheel is now lower than the frame. So the frame has more ground clearance. That's the one I tend to use this one for most generic designs. So let's start. Excuse me. I'm a bit dry today. Have a quick drink and I should be okay. Now, this is the basic frame I've made, and it's got 8 points for connecting the wheels on. Okay, so let's grab the wheel, and if you notice on the top right, it says suspension, wheel suspension, 5x5 right. Now, so first thing you must do is decide which is your front and back. Now, I made a slightly wider back and a narrow front, so that helps me decide that this is the front. And if I look at the front, that means that this is the left and this is the right. So let's put these ones on the right, like so. And what I'm trying to do is keep that nugget to the top and place the wheel. Remember, I'm in creative mode, so I'm going to be placing these blocks and they will be full. In survival, you will place the frame and then you add all the component parts as we've discussed before. So let's carry on and place, oh hang on, I've done something a little bit wrong here. We don't need that one. I had it on mirroring. Mirroring is a technique I will show you later. That's an advanced technique that I can show you how to do. So again, let's just place all of the wheels on the right, like so, and then we just scroll through using the scroll wheel to find wheels left, and then we're going to put all of the wheels on the left hand side, like so. Okay. Hang on, I was in the way for that one. If you don't have a wheel pop out, just delete it and try again, move out the way, or you can go into the K menu, which we'll go into later, and you can ask to add a wheel. So if you now look, this is the one, the frame with the downward pointing angles, and that gives me a huge, well, this is where the wheels are going to contact, look, that gives me a lot of ground clearance. So if we go over to this one and place these, that's the left, so we'll go on the left. And place those. Okay. And then we scroll through and find the right hand side ones, do the same thing. I think these might be a little bit close together. I probably should have come over one block, but it doesn't matter because I'm not actually going to use this design, so I should probably come this way on the back too a little bit. But let's just get these in to quickly show you what I mean. Now, this is using the upward facing angles, and you can see now the whole frame is a lot lower. Straight from the beginning, the ground clearance on these is significant because we've put these at, the wheels are at the height of the frame, and the frame is a lot lower. Yeah, you understand? So this is the design we're going to go with. Okay. Right, give me a second. We go, obviously, in order to get the wheels, one little thing I did forget is you go into G menu and you select the wheel suspension and then drag it down onto your toolbar into whatever position you require. Okay, easy. We have all the wheels on now. All Rovers will require a cockpit. Now there's two ways to control the Rover. Let's just stick with the basic one of adding a cockpit. Okay, you can add a seat, a remote control, and an aerial to make your designs a lot more sleek. But for the purposes of this tutorial, that's superfluous. So we're just going to add a cockpit. It's a new cockpit design. Okay, and unlike flying vehicles, this Rover only requires a small amount of power. Okay, Rovers don't require huge amounts of power. They do require enough to make them go, but I'm just going to add 2 batteries. That should be sufficient for most designs. Okay, so oh, hang on, that's not actually in line. So let's put that properly in line. There. Okay, that's it. All you require is some power and the wheels. Unless you're going with thrusters, but that's a whole different thing. So let's cut this away. I think we're going to have to cut a couple of these because I've used the big wheels. We're going to have to cut the frame a little bit to get these out. Oh, I just cut a wheel away. So let's put a new one in. 5x5 left. Nugget at the top and place it. Done. Okay. That's it. Simple. You must have the nugget on the suspension at the top. The reason for this, as I was going to explain earlier, is that we have some settings that we're going to go through in a minute. Okay, and those settings require a point of reference, right? So that they know which is up and which is down. But we've done it. So once we know that that's the top, when we do the settings, they will know which is up, which is down, and then they will adjust accordingly. So if you had it all different ways, it would not, they would adjust wrong and the wheels would be all over the place. So ensure that your little nugget is at the top on all of your wheel suspensions, with a bit of power and a cockpit. That's it. Essentially, that's a Rover build. Okay? Don't need anything else. We'll just get rid of the frame. Like I said, you just cut the frame away, and that's technically it. Done. Like with flying ships, you require a role for your Rover. Okay, so whether it's going to be for scouting, for transport, for whatever purpose, you will add that to the Rover later. Okay, but the important parts I need to cover with you really quickly first. First of all, jump into your cockpit and press the G menu. Now this brings up a different type of G menu than we're used to. And in any cockpit, this will bring up, if you press G, will bring up the blocks. And if you drag the cockpit down to number 1, which is what I want to do first, you get a list of things that you can tell that block to do by pressing the number that corresponds to it. And in this case, we want to find the handbrake on and off, which is this one here. Select that, and now whenever we press number 1, it will tell us that the handbrake is on or off. Right, so go ahead and put your handbrake on for now. Apply the handbrake and the vehicle will not move. Okay. Now, wheel settings. This is the crux of what I wanted to teach you today. Let's press the K menu and we select a wheel. Okay. Now, on the left, as we know, in the K menu is the list of items, lists of blocks attached to that grid. On the middle is the one we're more interested in at the moment. If you roll past, this is obviously the name. These are the ones whether you can see it in the terminal, blah, 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 toggle it on and off. Those are quite straightforward. But we come down to the checkboxes, and you have steering, propulsion, brake, air shock, invert steering, and invert propulsion. Okay, steering. Steering, this checkbox governs whether or not the wheel will assist in turning. A lot of people have different methods or ideas on which wheels are best suited to steering. You will probably best off figuring out for yourself what suits you, but personally, I like to have at least the front wheel set and the rear wheel set for steering, and that allows me to have a balanced steering. So I normally uncheck steering on the other wheels. Today I'm going to leave it as is because it doesn't really matter. We're not going into an in-depth design of this thing. We just want to show you how the wheels work. Okay, the next setting is propulsion, and the same for steering. This checkbox governs whether the wheel will assist with pushing the rover forward. Okay, again, there are various ideas which wheels should provide propulsion. I personally have all my wheels propulsion that are on the ground, so I check all of them to assist the propulsion. That's my personal setting preference. Again, you can figure out if you want to have less propulsion, etc. Braking, this box, so will tell you, if you check this, will tell you whether it helps with the braking or not. I personally on this have all my wheels braking. Simple, just easy. Air shock automatically increases the strength of the spring when the vehicle is going to land hard. Right? Again, this is a personal choice setting. So what you want to look out to, so this is a personal choice, and I prefer to have at least 50% of these on air shock. Right? This does not help with if you drive off a cliff or smash into something. That won't help. This is just designed for your everyday driving over uneven terrain, and you get a larger impact than normal. These will help mitigate that impact. Okay, and again, you need to figure out how much of that you require on or not. Inverting the steering and propulsion, I don't bother with these. You can, and it helps you. It might help you in your design, but personally, I always leave these alone. Now, let's go to the slide bars. The slide bars are steering angle, power, strength, height offset, friction, speed limit, propulsion override, steer override. Steering angle. This will determine the angle at which the wheels will turn when a direction is input via the controls. And this means if you press A and D when you're moving along, how steep the incline, the angle the wheels will turn at. The default is 20%, and that's pretty fine for most generic rover needs. If you have a very fast rover, you might want to consider dropping this down to 15% or so. This will help you prevent flipping over when you turn. You must remember the steeper this angle and how fast you're going may result in your rover to flip. And on the other side of that, if you've got a very slow and heavy rover, you might want to turn this angle up to 25-30% kind of area. That will help you turn faster and not have the turning circle of a brick. Okay? But also always be mindful of how fast you're going to be traveling. The center of gravity on your rover, if it's a high center of gravity, if you've got a very tall design and you turn suddenly, it's going to flip over. If you have got a very wide wheelbase, very low center of gravity, you can have that angle quicker and it will maintain itself a lot better. But again, you need to adjust these to your own preferences. But the generic settings at 20% is fine for most things. Power. Right. This setting denotes how much power will push through the wheels. Now, You might think, let's just set this to 100%, right? That's got to be fine. Well, no. Actually, if you apply too much power to the wheels, they will lose traction and just spin in place, and your Rover goes nowhere. The other side of that is it might gain too much traction and you just fly off in an uncontrolled manner. Okay, so you will need to focus on the power. The 60% is good. It's a good starting place. I would advise experimenting with this, dependent on your Rover's design and what its function is. It does go hand in hand with friction. Okay. Also, power. You might need to input more power when you've got very steep terrain. So bearing that in mind. I personally denote how much power goes into my through the wheels. Sorry, forgive me. Depending on how much the Rover weighs. Now, this is a very lightweight design. It's only a frame, so putting too much power for it is going to make it very unstable. Okay, so we probably would actually just drop this to 50% or so for this design because it's got nothing on it except a couple of batteries. Right now, strength. The strength is denoted how strong the springs are and how easily they will compress. You want this to be reasonably low but not too high, but you don't want it to be too low. Again, if you're this is dependent on how heavy your Rover is. If your Rover is heavy, you will probably want to increase this strength. Now, the generic for this is 6%. I tend to use 12 on most designs. If it's very heavy, I'll go higher. Okay, so strength is the compression of the spring when the ride height goes on. If you drop this onto its wheels and it hits the deck straight away, you know that this needs more strength in the springs. If it's bouncing and you're not getting enough clearance, you might need a bit more strength in the springs. Okay. Ride offset or height offset. This is how high your Rover sits above the ground. Okay. And it's at minus 45.8 centimeters. Now, this is the actual height. You just want to adjust this dependent on your design again. If you have this too high, it becomes a higher state. It raises the center of gravity every time you raise this up. So be aware of that and keep that in mind. So you probably for your first few designs you want to keep this as generic as the height is. The default setting is usually pretty good. If you want to lower it to get it through a low area, you can lower it. If you have some people design with a connector on the bottom, so you can ride along and come to the port where you've got the other connector on the base on the ground, and then lower your Rover down to make that contact. That's one way of making the design. I would advise for them now keeping that ride offset as it is, but you will experiment as you go on. Friction. Okay, now friction is what how hard the wheels will interact with the ground. Okay, that sounds very silly, but that is what it is. It will aid in the grip of your Rover. If you have too much friction, and again it's linked to the power, if you have too much friction going through the wheels and low power, the wheels will not turn because they will just grip the ground. If you have low friction and high power, the wheels are just going to spin. So you need to counter the power with friction and balance those together. Again, for this design, I would drop this to about 45%-ish, something like that, because it's a very, very lightweight design. But the generics are pretty good, but you need to consider friction as opposed to how much power you're putting through the wheels. If you've got a lot of power going through the wheels, you might want to up your friction. If your vehicle isn't moving it fast enough, you might want to lower your friction. Okay, so speed limit does what it says on the tin. 100 kilometers per hour is more than enough for most, more than sufficient. You don't really need to put that speed up anymore, because 180 kilometers an hour is very fast across the ground. And remember, if you go faster and you turn, you're more likely to flip over. And also, the faster you go, the harder your wheels are going to impact over uneven ground. Okay, simple as that. The two bottom ones there, propulsion override and steer override, those are more to do with automatic turning and automatic driving, and you would tend to use those with drones. Not necessarily, but I would ignore them for now and keep them at 0%. For now, just ignore those. Okay, so what I want you to do now is go to the left-hand side, click on the first wheel, drop all the way down, pressing shift, and group select all of these. You can do that with control, individually clicking them, but I want you to make a group out of all of the wheels on your Rover. Over here, I want you to type wheels, and then save. Okay, and then you can click on anything else, just click off of it. Now, if you go to up here where it says wheels with a asterisk before and after, that denotes that it's a group. Any group, that whatever you type in here will be between those two asterisks. But if you notice, all I have to do now is select that button, that group, and all of the wheels are selected. So I can now set all of my wheels at the same time. Okay? So I don't have to set them up, go to the next wheel, set it up, go to the next wheel, set it up, and so on. You can set all of the wheels at the same time by grouping them. Now, once that's done, come out of that menu, and I want you to press 1 to get rid of your handbrake, and you can use WA, S and D, and there you are, you've done it. It's a Rover, it's moving. Okay, using spacebar as your brake and 1 as your handbrake. This is it. That's it. Now, if you know, you can see on this, it's got quite a lot of space that I can put stuff on the back. We can make this into anything we want, whether it be a troop carrier, cargo carrier, a small gun platform, exploration rover, so we can put a lot of cargo on it. If we're going off to, we can put anything we want. Okay, and the only other thing really to add to it would be lights. So we go in to G menu and we find the spotlight there and add some spotlights to it. Okay, and with the spotlight, you just want to make sure that that part with the grille is facing out. There, done. Using L inside the cockpit will turn the lights on and off. Simple as that. You have made a Rover. Because it's night time, we got the lights on. Look at that. How simple. Well done, you. You now know enough about wheels to make yourself a Rover and what the requirements are for that. Simple. So thank you very much. I will see you in the next episode. Take care and ta-da.